Okay, I think this question here will be a good example of speed, distance, and time. So below is a simple diagram of a racing track with the distances between checkpoints A, B, C, D, and E. Okay, how long is the entire track? So this one's pretty straightforward. What we've got to do is add them all together, but there is a little bit of a twist, which is 1 mile is 1.6 kilometers. What I would do is, before turning any of these into miles, I just add them all together. So 1.2 kilometers from A to B, add 0.4, add 1.3, add 0.7, add 0.5. Now that's our total distance in kilometers, so it's 4.1 kilometers. Now, to turn this into miles, we've got to divide it by 1.6, which will give us 2.5625, which is what we got there. This is just a lot to do with exchange rates. To turn that back into one, you have got to divide it by 1.6. I think you just got to memorize that. Now, Chanel drove from A to C. She drove at 240 kilometers from A to B. However, from B to C, she drives at 72% of her original speed. How long did it take her to drive from A to C? Okay, so first of all, let's work out what 72% of her original speed is. Now, if we're trying to work out what 72% of something is, we need to know 72% is 0.72. To work out 72% of 240, we'd have to press one button. 0.72 times 240. Now we do that on our calculator and we get 172.8 kilometers an hour. Now we move on to the distance equals speed times time bit. What I like to think of it as is a pyramid, okay? I'll just do it quickly here. This is what me and Henry did in physics all the time. Is we got this pyramid, and whenever we were trying to work out one of the things, we would, I'll show you in a second, I just need to make it first. So let's say, for example, I'll just make this little box here. If we were trying to work out distance, we would do speed times time, because we're on the same level. If we were trying to, speed can be V or T. If we're trying to work out speed, we'd cover it, and we do distance over time is speed. If we're trying to work out time, we'd cover it, and we do distance over speed equals time, and so on. That just takes a little bit of practice, but I think this pyramid here really helps, and you can write that down in the notes in the exam. Now, how long did it take her to drive from A to C? So we're trying to work out time, so that'll be distance divided by speed. Now, this is the speed, add it to memory. The distance from B to C is 0.4 kilometers, so 0.4 divided by speed, which is in memory, and that gives us about many seconds. Well, that's in an hour, so we times that by 60 to get minutes, times it by 60 to get to seconds. That's 8.33 seconds. So I'll write that down in my notes here quickly because I've got memory used. So 8.33 seconds. The complicated thing is when you worked out the time there, that's in hours. So originally we had a decimal of hours, but if you times time in hours by 60, you'll get time in minutes. Alright? And if you multiply the time in minutes by 60, you will get time in seconds. That's what I just did there. Now we're going to have to do the same here again. So 240 kilometers an hour from A to B. So that's 1.2. We do our distance, which is 1.2, divided by the kilometers an hour, which is 240. And that gives us 0.005 hours times by 60, 0.3 minutes times it by 60, 18 seconds. Now we add that to our 8.33 seconds we had earlier on, and we get 26.33, which can round to that. That one probably took a bit longer, but you just need to get used to it. Some of the questions in these papers are quite hard, and some of them are quite a bit harder than others. what I would do if I had one like this, if it's just taking a bit longer, I'd press the flag button so I can go back to it later and do the easy ones first. Okay. Max completed the full circuit, A to A in 59 seconds. What was his average speed? So, we worked out that the distance before is 4.1 kilometers, I'm pretty sure. I'll just double check. Okay, so 1.2, add 0.4, add 1.3, add 0.7, add 0.5. Yeah, 4.1. Now, we're still trying to work out, we're working out speed this time. So we'd get the distance and we divide it by the time. Now, because that's in that's in kilometers, we need to work out the kilometers per hour. So we have to turn the time into hours, which is 59. And then instead of timesing it by 60, we'd have to divide it by 60 this time. So that gives us this. Now, distance divided by time, that's what we do. Oh, wait, one sec. The thing about this calculator is you've got to do it in a really tricky way. Now I'll do it again. 59 divided by 60 divided by 60. The thing is, you've always got to do the dividing bit on the bottom first, then add it to memory, and then after that you can do the top bit divided by memory. That's just how it is, sadly. It's a bit weird. That gives 250.2 kilometers an hour. Now, Rebecca raced from B to A by C, D, and E at an average speed of 130 miles per hour. How long did it take her to complete this? So B to A, but through C, D, E, A. Average speed of 130 miles per hour. So we'll do the same again. We'll get the distance and we'll turn it into miles per hour. Sorry, miles. So that's B to A, 0.4, add 1.3, add 0.7, add 0.5. That gives us 2.9 kilometers divided by 1.6. That'll give us 1.8 miles. Now, that's our distance. We divide it by the speed to get the time. 1.8 divided by 130. Oh, divided by 130. Times it by 60 to get to the minutes. Times it by 60 to get to the seconds. So that's 50.2 seconds. 50 seconds. Now let's mark and see what we get. These questions are kind of the harder ones because you've just got to practice a lot. I mean, a lot of it is just formulas that you've got to try and remember, sadly. Okay, alright, on to the next one. Okay, so got another distance speed time question here. Below is a list of race times for the 5 fastest horses in a long straight race. All horses started at the same time and ran a race of 5 kilometers, which is this many miles. What was the average speed of the fastest horse? Okay, so we know the fastest horse will have the quickest time, so it'll be the lowest time, which is 4 minutes and 10 seconds. That's asking for speed per hour. So what I would do is I would convert this into seconds first. So we know that 4 times 60 is 240 seconds for 4 minutes and 10 seconds. And as we've done before, to convert seconds into minutes, divide by 60, and to convert minutes into hours, we divide it by 60. So we divide it by 60 to get into minutes, and we divide it by 60 to get into hours. Okay, so this is our time. Now we add that to memory. Now we're trying to find the speed. So speed, cover it, distance over time. Now we get the distance, which is 5 kilometers divided by the time. That's 72 kilometers per hour. That's just done with that bit. A length is a unit of measurement equivalent to 8 feet. If Nasdaq beats Heffyard's Pride, I don't know. How many lengths did he win by? Okay. So this is where we go into the conversion thing here, alright? So you can see that 1,000 meters is 3,000 feet. Okay. So let's simplify this down a little bit. 1000 to 3000. That's basically the same as 1 to 3. So it means that 1 meter to 3 feet. Now, if we divide this by 3, we'll get the amount of meters we've got. So 8 divided by 3, that's 2.66 meters in the length. Okay, now I do 4.8 divided by this. Okay, so 4.8 divided by 2.6666, 1.8 lengths. That's just done with that bit. Next year, the organisers want to increase the length of the race by 40%. How many miles is the new racing distance? Okay, let's convert the 5k into miles first. So what this shows us is that 1000 meters is 1 kilometer, is 0.625 miles. Now if we times it by 5, we can get 5 times 0.625, which is 3.125 miles. Now if we're increasing the length by 40%, it means we are appreciating, so it means we're timesing length times by 1.4, because remember we have to add the 40% onto the 100, so we get 140%. So we times that by 1.4. No, times that by 1.4. We get 4.375 miles. Round that up to 4.4. Okay. Now one more. The average age of the horses. Okay, that one there is pretty straightforward. Another bit of averages. The mean is numbers added over how many numbers. So get our numbers added together, which are the age. So calculator out. 7 add 6 add 9 add 12 add 11. Divide that by 5. The average age is 9. And let's mark that. See what we get. Alright, good. Clean sheet.